Okay, so this is the propulsion lab, and you can see it's pretty crowded in there.
Yeah.
They have a mixing station. We used to use just a small little mixer, and we still use it for subscale. But when we started building big motors, we actually found a big giant, like the kind you see in a big bakery,
Yeah.
and so we've had to buy infrastructure to make that happen. This is a picture of the mixing process. Students wear, protective eye gear, protective clothing, and breathing gear. Um, you're mixing ammonium perchlorate and metals, and so the we have very extensive safety protocols in place to make sure that students are safe while they're mixing. Here's our aluminum that they're getting ready to mix to the propellant. Yeah, that's great. Yeah, it's a long and tedious process, and kind of when I see a picture like this, it looks like they're making a cake. Yes, a very high impulse cake. Yeah. Oh, and here's Amar. Yeah, he's casting the grains. They have really have developed some very nice protocols for doing that safely. This looks like they were assembling the subscale rocket that they did for their two-stage launch, not this past weekend, but the weekend before. So this is where they're assembling. They had this looks like the upper stage. This is the mid stage, and then they had essentially three kits that they kind of glued together, and then were able to test that it goes up, it separates, blows a charge, and separates it. Upper stage goes up, upper stage lights. It was to test and then be able to recover the upper stage. This was a test of the full-size solid rocket motor. So here is the motor on a test stand, and it's a full size, so it's about maybe 3.5 feet and about 4 inches in diameter. And they put it onto a stand, and they light it. They can measure thrust, they can measure pressure, and they are seeing whether or not the motor casing, the metal that holds this whole thing and the pressure, will in fact be successful in being able to do that. Data is really important, and data is hard to get. It's real hard because the sensors are kind of tricky. They have to download the sensor data onto their laptops, then they have to post-process the data in order to get nice pressure curves to see what the performance of the motor actually is. It's hard. Yeah, a lot of hard stuff.
We have 5